Yeah, good evening to you. Thank you, team. Thanks for the opportunity. So here, I'm going to talk about that machine learning. So how we are going to apply in the the data set, and how we are going to use that machine learning techniques in our programming. So you know that other languages there, but I choose R for the machine learning techniques to apply to find and create the model, which is get the data set from the Kaggle. Okay, so so these are the topics I'm going to discuss today. So what is the machine learning, and then so what kind of data sets I get from Kaggle for my competition, and then what the problem, and then how we are going to see the data set. So from the data sets, how we are derive the problems, and how we are going to match the problem with the data set, what they given in that variables. Okay, so from the data set overview is we just going to see what is the unique fields or what kind of data they are given for us for the model creation and the prediction. So the last thing is the dataset cleaning process. The dataset cleaning process is the very important process before we are going to create any model. Since so in the datasets might contain a lot of junk values or zeros, maybe that variables not used for us during the model creations, but that needs to be avoided before we are going to create a model. So next one is algorithm and model selection. So after we cleaning all the after we done all the cleaning process in the data set, then we need to choose our algorithm, what kind of algorithm we are going to use to create this model. So the last one is predict process. So the prediction. So okay, so once we create the model and everything, so how we gonna create what kind of prediction we're gonna get from that model. So either it is percentage wise or it is a numerical. So that information will be get based on our predict process. The last one is R code. So what kind what I applied this computations, that code will shown here, and the submission value. So once we create the prediction value by applying all the model and the techniques, so you have to submit that the data set to the Kaggle. So the Kaggle team will work, and then they give some score to us. So based on the score, they evaluate us our work. So the last one is about I just give my myself. So machine learning. So you all know about that. What's the machine learning? So it's just like a computer. We just give opportunity to the computer to learn and then act like a human. Okay, so so once we create the model, so we just continuously feeding the data and increase that model's robustness. Like so we are creating a model, but after some time you just give more parameter and then more data, and if you give like 2,000 3,000 data first time, and next time you just give 50,000 1 lakh data, then the model will give a more prediction, the accuracy will be increased. Okay, so the data set I choose the Santander bank data set from the Kaggle. So for my from it's listed under the competition. So I choose this Santander value prediction. So after I choose this data set, I realized why I choose this, because of it's having a lot of variables. I like they given like 4,000 plus variable in the data set. So I don't know which one I'm going to choose for model. So this is a great confusions after I got this one. So my best advice, if you are the initial programmer, or if you're gonna do any competition, if you want to participate in any competition by using R, you just to choose any simple data set. That will be very helpful to move forward. Okay. So the problem statement. So the Santander Bank actually it's actually Boston-based bank. So they have many type of medium to interact the customer, like ATM, both phone banking and digital marketing and branches. So they want, the bank try to understand the customer's potential, transaction potential of the customer. So some of the customers will do more transaction through digital bank. Some of them are going to ATM, some of them are going to directly branch, and some of them using the mobile banking. So they want to try to understand the business, customer potential transactions. If they identify and segregate the customers based on the transaction, then they will give more. They will give us. They will increase. They improve their service in the timely manner, and they easy to provide the. For example, if a customer doing more transaction through digital banking, then they will connect the customers through the digital banking and give offers, and then they directly whatever the communications they want, they is to reach out the customers through the digital bank. So this kind of things they want to understand to segregate their business. For example, if we find more transaction in the digital bank side, so they will invest more money on the digital bank side and increase their service on the particular domain. So this is a problem statement here. And then data sets. So in the data set contains many anonymous data sets, variables. So these data set variables have numeric and string ID column. There is many numeric data types, and then string. ID is a string. Okay, so the ID is a unique value, and the other all variables are numerical. So it's kind of transaction that each and every customers will do, right? So the in the Santander competition, so you could see the they given the 3 files, train, test, and sample submissions. So the train data set you already know. So many of the competition, so they only given the data set alone. So after we getting the data set, we just segregate the 70% of data as a train data set and 30% of test data sets. So based on the 70% of train data sets, we create the model. So once we create the model, then we give a test data set as an input, and then getting the predict values. So in this way we are just doing the other competition, but in this case they are given train, test, and submission. Train data set actually they given an ID and along with their target target value as well. So in the train data set they given ID and target, and along other variables. We just to find out so how they are gonna find out that target value. So in the data sets, so we just want to correlate the variable first. Then based on that we find out the target in the train data sets. So based on the train data set, we create a model, and then we just give all other variables and find out the target values. So the train data set we have ID, target, and other variables. But in test data sets they given only ID and variables. We need to find out the target value. So the submission is submission is only the ID, and then we have to give the target values. So what we found from the prediction, we just given in that separate column and submit the data set to Kaggle. So they will do some analysis on their side, and then they will provide our score in the leader scorecard board. So data set overview. So in the data set overview, so first of all we just find out how many rows and columns we have in the data set. So here actually we are using the train data set, dimension underscore description. Train means train data set. Here they given 4459 and 4993 columns. So 4499 is rows and 4993 is columns. So when you see the data sets, you could see the number of rows or number of columns are high than row. Okay, so the challenge is, so we need to find out the correlation factors of each and every variables with the target value. Okay, so in the test data sets we could see around 49k of rows. They given more rows, but the columns are same 44992. So the only difference between the train and dataset column is, so in the train data sets they already given the target column, so that we they already found out, and then they provide the train data sets. But in test data sets they provide ID and other columns, but we need to identify, we need to find out that target columns. Okay, that's our problem, we need to identify. So columns are all, they didn't give a column names like unique column names like a customer, transaction number, ATM or digital kind of stuff. They only given an anonymous variable like this. So ID and target. ID is a unique, so it specifies the customer, and then target. So target is our number of potential transaction, and other all column, others all are columns. This is the column names. So these are column names, but all each and every columns have numerical value. So it's a transaction, number of transactions they done for this particular variable. So for example, next column XOD, so that they have some column, some value like 10 or 20 for each and every customer. So this is the data set. First, when you see the data sets, this is a data set and this is a column. It is the columns, it's not a value, it's all the columns, ID and target and other variables. So after I seeing the all data set, okay, this the number of columns and number of rows and how the columns are defined in the data sets. After finding that, so we move on the data cleaning process. So before we, when you go into data cleaning process, first you need to find out is there any non-missing values are there or not. So in this process, what you are going to get from this process, like you will get a clear data for your model. So if you give any junk values to your model, the model will run and give the unpredicted value to you. So that's not, it will not help to you for your prediction, right? So that you just give a check whether you have any missing values in the train data set or not. So after that, the target value, like, so they already found the target for each and every customer based on the variable and then given in the train data set. So where we need to they just find out the range. Okay, what kind of range they given. They say, the volume of that target value, minimum and maximum, is already given here, and then I just find out that summary of the target value. So it's what is the minimum value, what is the mean for that, which is maximum. So when you find that mean value, so when you find the prediction, okay, so if you get the value close to that mean value, so your predictions would be 50% accurate, since you will get a mean value like 15,944,923. So your target value, after you find the prediction and you apply, you given your test data set, and then you get some prediction values. When you find that close to 59 or 60 something, so you might think like, okay, you did some good process on your prediction. So after that, so once you found that, okay, these are the items we have, we don't have any non-missing values in our data set, and then the range was around E3E04 and 4E07, and your summary for, you just find out the minimum and maximum and mean values. Yeah.
What's the metric that you're being judged against in this competition? Is it the mean square error of your predictions versus the actual targets?
Sorry, which one are you asking? Mean value.
Mean is the mean square error. Is that the what you're being measured on?
No, I'm not measuring anything on here. I just want to understand the data, what they given to us.
No, but what I'm asking is when you submit your answers back to Kaggle, is the where you place in order, is that based on the mean square error between what you submit on in your answer versus what the actual is? Is that the metric?
No, actually that's not a metric.
I think it was that root mean, it's not mean squared error, but it's the mean squared log error, I think was the
Okay.
is the validation metric.
I'm not familiar with this one, so.
So after I see all the values on non-human, I mean we don't have any non-missing values and the range and the mean found that, then I just give just to clean the data set by using this logic. I mean to top all 0 value variables. For example, if any one of the among the 4,900 variables, so if any one of the variable have only zeros, we just drop down that variables alone, okay, because we don't want to that variables, because there is no value in that, we just only have zeros, so we just drop those variables before we for our final data set, to prepare our final data set. So here I just apply, utrain is on a variable, I use a variable, the train is a data set, that apply and train comma 2. So the 2 means it's a margin, so when you're gonna see the syntax on that apply, so apply open bracket and then your data set name, then 2 is our margin, so it means your columns. 2 means columns, 1 is a row. So function x equal to all x equal to 0, so it means like so any one of that your variables have any zeros, you just drop down those variables from your data set. So after you find your final data set, once you drop all the 0 contain variables, then you will have a data set like utrain. So after that you just find out all unique variables here. So this one utrain 1 and utrain not equal to duplicate the utrain means if you see a variable a and b, a, b, c, d, okay, so the a variable we have a value like 1, 2, 3, 4, but the c variable also having the value like c 1, 2, 3, 4. So these two are considered as a duplicate, okay, in a data sets. But when you are seeing that any data set with the huge columns or huge variables, so you need to find out like whether there is any similarity. Why I remove this duplicate? So when you do some correlation between the 2 columns, I just got the correlation values 1 because the both columns are duplicate, right? So I don't find out any significant correlation between the 2 columns. That's why I just drop all the duplicate value contains columns. So after you remove all the zero contain variables, and then you just remove all duplicate columns from the data set, so you just find out the correlation between the variables. So first 2 columns like id and target, so both are already they are given, so we know that they are unique. id is a unique, and then id is considered some customer name or customer id, and target is they already provide the variable, so we don't want to use, we don't consider the target variable here. We just consider all the 4,000 variable here. So just to give a 3 into n call utrain 1. So utrain is already we found that after we did our drop all non-zero values, 0 values contain and the unique values, then we have the utrain. So here we just do the correlation between the columns, each and every columns, okay. So here instead of that you doing that correlation factor, you can do like you just find out, you just create a model, and then you just do find out the p-value. So probably in most of them here of that the p-value concept. So in the based on the p-value, like, so there is some significance value over there, the 0.05, so it's a null hypothesis testing purpose. So in case if you found that any of the variable which has the p-value like 0.0 less than 0.05, you can take that variable as one of the factor for your final prediction. Otherwise you can drop the variable, since this is the one way. So another way, you will choose your variable based on your p-values, okay. So once I found everything, then I just the correlation factors will be table format. I just convert it into the data frame format. It's a variable 1 and variable 2. So how that particular variable will correlate with another variable, So the value will given as a frequency. That frequency have the value. That value is value is represented by the how much correlations that we each and every variable have. So after I found the correlation, I just drop down all the negative correlation values and then not equal to 1 values. So which is even like so it is more like it give more robustness to my it's easy to choose the variable which I want to create the model. Okay, so here the topmost correlative factors I just change that variable 1 variable 2. Let's take only that variable 1 and 2 because I don't want that frequency because I already found that. So in my Windows system, so I could not find I could not run all the variables with using all the variables to run to predict the model. So I just drop down some of the variables. I take only the 400 or 500 variable from there. So top 500 or 300 variables from the data set. So among around 4,900 data set variable, I choose only 400 500 variable for model to create the model. Okay, so after I getting that variables from the data set final 3, I just unlisted those all columns because in my data sets I have the variable 1 and variable 2. So we have the variable the both where 1 and where 2 represent that variables. So just I remove that all the final 3 has all v1 and v2, right? So variable 1 and variable 2. I just unlisted all the variables and bringing everything as a one column, and then I just remove the all duplicate values, getting only the unique values from that. So after now I have around 500 variables from 4,900 variables. We initially we have the 4,900 variables. So from 4,900 I choose only 500 variable. So that variable I need to choose the data from the test data set, train data set. So I only choose only those variables value from the data set. Okay, so for example I have only 500 variable that train data set have around 4,900, right? So I need to choose only 500 variable and the corresponding value from that. Okay, so after that once I receive that once I string the data set 500 variables and ID and target, then I will have the data set like F1 where I just have to drop down that ID to find out that predict model. Okay, so this data set, okay, so they already given all data set, all variables and the corresponding target variable, so target value. So here I just choose the linear regression model and to find out that to create the model for by using that data set which I found that an earlier step F1. So here this coefficient, right? So estimated standard code, t value and p value. So instead of you are going to that correlation model, you can choose that p value. You can get the variable for your model. Okay, so after you create that everything, then you can apply that linear regression model, and then you get when you create a model, then you apply your prediction techniques over there. So this is the prediction. So yeah, after once we create a model, we need to choose the test data set and the test data set. So we already found that best best variables, right? So we just give a test pick the test data set and get only the 500 600 variables from the data set and apply to find out the prediction variables. So here I just give a MO as a model that I already created, and the new data set subset, and test one is a test data set. Select, I just remove the first ID, so and then I founded that prediction value for all the other variables, and the type equal to response. So response means I just need only the numerical value from the prediction. That's why I given the response. Otherwise you give some term and then link. So where you could TAM usually give some percentage of values for each and every column. So, but I choose a response for numerical value, so that I just give a type equal to response. So after I found the P1 value, I give a sample submission where I just already found the target value. In the submission, we have the data set contains ID and target. So the target value has to be replaced. The submission, sample submissions are already given by the Kaggle, Santander bank. We just replace the target value by our predicted value P1. So here I just write the file into my local system. Then I will upload into Kaggle website. So here this is the code I wrote for the competition. So these are the things on the length BV and PV and PST variables. Then I change that variables a character and append that ID and target. Then a final data where we choose only the record variable from there, and then we apply the model. Then I give a test data set, choose a test data set. Then we apply the predict logic, and then whatever we predict from that process, we just add that sample submission data set, and then submission data sets will be submitted.
Keynote crash?
Yes.
Let's see if I can fix it.
Does that one work?
Yeah. Sorry. Yeah, system.
Okay.
Yeah, my submission value, like, so my data set, final data set will be ID, and the target value will be like this. So after you got this value, you just imagine, okay, so main value will be in 59 something, so 54, so around your prediction will be 40 or 50% match with it. Yes.
So it sounds like you're saying that the way you selected features was to look for data that had a high correlation, and then you use that use that as your features. Is that correct?
Yes, when you get the correlation data factor, so that's the correct, right? So I just only that which one is which variables will more support to your final target variable. So we just choose from that. So in this competition data set, your trained data set, right? So where you have a target value, right? So based on that, you can just correlate other variables and get that variable numbers.
Are there other ways to select features that you would consider, or any thoughts on that?
Other way of choosing the variables, right? That's what you're asking.
Of selecting features, like for example, perhaps looking at the problem and thinking, what type of data could we, or what type of information could we extract from the data set to use that as a feature? Kind of like using your own logic to select a feature rather than just, correlated data as a feature.
Yeah, I think you may apply that p-value concept, or else use a correlation factors. Otherwise, you can choose other techniques. I'm not sure about that, but probably is made there. But
And I'd add, in this case, I don't know if you caught from the beginning, the features are anonymized, so there isn't a lot of intuition to be gathered out.
One suggestion I was going to make with the correlation was that you might look to, I didn't see if it was the standard correlation function, but assuming it was, you probably want to change the range more to be taking out value is close to 0, but not excluding negative. So negative correlation close to 1 would still be a information relationship. It's just saying that as one goes up, the other variable goes down.
Yes.
And so that would still be useful in your model. And it looked like you were only taking the positive part of the correlation part. So you may be filtering out strong negative signals that would be useful.
Okay. So after I submit that reduced scorecard, then I got a score like 2.08. So it's a normal score. It's not a good one. So I saw many of them score like 0.48. I mean 0.48. It's a top one. So the next one. So about me. So I just learn a new concept and apply wherever it needs. It's my passion. And then I write some blog, and then I published most of the blogs in the datasciencecentral.com, so you can go and read my blogs over there. And then my personal blogs are roankint.com and WordPress, so if you want you can go and you can see very emotional blogs over there. And then but your technical blogs will be published in that datasciencecenter.com.
Thank you.
Thank you.